Last FRQ, again 4 points. I'm looking here and I see A, B, C, D, 1 point each. So, oh, my timer. I have time left over from last time. It's still running here. Let me turn it over anyway and see if I can do it in less than 10 minutes. Now, students given a solution of phenol red, that's an indicator of unknown concentration. Solutions of phenol red are bright pink under basic conditions. That's pretty nice indicator. Pink, so it's probably absorbing somewhere in green or something. A student uses a pH probe and determines that the pH of the solution is 11.2. Calculate the hydrogen ion concentration. Oh, okay, hydrogen ion concentration. We're given a pH is 11.2. I mean, we know how to change that into hydrogen ion concentration. It's going to be a small value. Hydrogen ion concentration is going to be 10 raised to the 11.2. Let me get my calculator out. On anti-log, we're going away from the log. We're going away from the pH. Where's my anti-log? Here it is. Second function log, there it is, 10 raised to the, don't forget the negative sign, not minus, negative 11.2. I mean, if you raised it to 11.2, you'd have trillions of molar acid, which won't happen unless you're on a neutron star. We should get a small number. It's a basic solution, so we'd expect a pretty small number. Yeah, 6.3. 6.3 times 10 to the, there it says, negative 12. Oh yeah, negative 7 would be neutral, or close to it. Molar, H+. Really, really low concentration because the hydroxide ion concentration is a little bit higher. One easy, fast point. Damn, I mean, that's not AP. Okay, here. The student analyzes a sample of solution using a spectrophotometer. Okay, we know spectrophotometers. Here's absorbance. Here's the pink, not the pink, the green that's being absorbed probably. Set at a wavelength of 559 nanometers. That's where the stuff is absorbed. Measure the absorbance of the phenol solution at 559, which is 0.35. The measured absorbance, how much it absorbs, is 0.35. Here's their absorbance, 0.35 right there. Based on the calibration curve below, what is the concentration of the solution in micromolar? 0.35. And do we really have to be a chemistry teacher, a student for this? About halfway through there. Halfway there. Concentration. That's just reading a graph. I'd say 5.5 times 10 to the negative 6 molar, but we'll just call it, they want it in micromolar, so we'll give it to them in micromolar. And these dyes, they're very amazing how much color they absorb and how they produce those colors with such super, super small concentrations. But wait a second, I'm rambling. So let's go on to the next question. We got 2 more points. If a student mixed 10 mLs of distilled water with 10 mLs of sample, okay, our sample would be about, 2.2 micromolar. The volume is increased, so the concentration is lower. Would the solution have an absorbance greater or less than or equal to the absorbance of the original solution? 5.5 here, about, what was that, about 2.2? Yeah. Lower, I mean, I could even give you the value. Justify your answer. Lower absorbance. Less greens absorb because concentration of the, what was it, phenol red is lower. That's it. Just a few words. Got plenty of time. Let's see what D says. if a student measured the absorbance of the solution at a wavelength of 650, that's more in the blue range, indigo, violet, well, yeah, violet, would the absorbance be greater, less than, or equal to the absorbance of the solution to 5959? Now let's go back to the original way. The student using maximum absorbance is 559. That's what they tell us. So less than max absorbance. By the way, they don't deduct for spelling or bad handwriting or printing for that matter. Less than max, 650 nanometers is less than maximum absorbance. So more light gets through. And less absorbance. Measured. Okay, did I answer? Would the absorbance be greater or less than? Less absorbance. So I answered that, and I justified because 650 is less than maximum absorbance. So more light gets through. That's it. Wait a second. Is there more? No, there's no more. We finished the exam and whoa. All right. I guess I go back and check stuff and like. But that's the exam. This one, I think this one is a little bit easier than most, but still, that's the one. This is the exam that was given for students, and you can figure out your own score, add it to using the formula I have, your MC score, one of your MC scores that you've taken, and figure out roughly how you would have done this on this exam. Okay, that's it. Very, very good.